Right now, somewhere in southern China, cars are driving through clouds, not above them, through them. The road they're driving on sits 625 meters above the canyon floor. That's higher than the roof of China's tallest skyscraper. To put that in terms your body can understand, if you dropped a stone from that road, it would fall for 11 full seconds before it hit anything. 11 seconds of silence. Then rock. And to build the highway that leads to this bridge, engineers didn't go around a mountain. They didn't tunnel through it either. They split it in half. But here's what nobody is talking about. China didn't build this bridge to move people. They built it to move money. And the way they did it is one of the most calculated, coldly brilliant infrastructure strategies in modern history. Once you understand the full picture, you won't look at a road the same way again. Guizhou Province, China, 90% mountains, not rolling hills, not gentle slopes you could grade and pave over. Sheer, vertical, almost hostile terrain, the kind of geography that feels like the earth itself decided it didn't want to be inhabited. The people here have a saying passed down for generations: not 3 feet of level ground. They're not complaining, they're stating a fact, a geological verdict, a sentence handed down by the landscape before anyone alive today was born. For hundreds of years, this province was physically trapped. You could look across a canyon and see a town 1 kilometer away. A town you could probably shout across on a still day, and it would take you 2 hours of sharp turns and steep drops and white-knuckled driving to reach it. Farmers watched their crops spoil before they could get them to market. Students couldn't access better schools. Doctors couldn't reach patients in time. Families lived kilometers apart and may as well have been in different countries. A young person with ambition had nowhere to take it. The mountains didn't just make life hard. They manufactured poverty generation after generation, as reliably as any factory, except this factory had been running for centuries and nobody knew how to shut it off. By 2012, Guizhou was one of the poorest provinces in all of China.
Not slightly behind, not catching up slowly, genuinely structurally poor, in a way that normal economic policy couldn't touch, because the problem wasn't policy, it was physics. The government had a decision to make. They chose to go to war, not with a country, with geography. Here's a number that should stop you cold. 32,000. That's how many bridges China has built in Guizhou Province. Not all of China, one province. 32,000 individual structures, each one punched across a gap that used to make trade, travel, and basic human connection nearly impossible. 32,000 answers to the same question. What happens when a mountain gets in your way? You build over it, and then you build over the next one, and the one after that.
You don't stop until the province is stitched together like a quilt, and the geography that imprisoned people for centuries is just scenery. But among all 32,000, one stands above every other structure on Earth. Literally, the Huajang Bridge. Stand at the bottom of Huajang Canyon and look straight up. The bridge deck is 625 meters above your head. The structure stretches nearly 3 kilometers across the void. And before it existed, crossing this canyon took 2 hours of slow, grinding, dangerous road through switchbacks that made even experienced drivers nervous. After it opened, that crossing takes 2 minutes. 2 hours, 2 minutes. That's not an improvement, that's a different world. That's the difference between a province that's connected and one that isn't. Between goods that reach market fresh and goods that rot in transit. Between a child who can get to a good school and one who can't. That 2-hour gap was the gap between poverty and possibility. And China closed it in 2 minutes. But the bridge is only half the story. To connect it to the rest of China, engineers needed to build the S57 expressway, 150 kilometers of highway through terrain that was almost impassable even on foot, let alone by machine. And right in the middle of the planned route sat a problem that couldn't be negotiated with or routed around: a massive, solid mountain. Not a hill, not a ridge, a mountain. The kind of obstacle that, in a previous era, would have ended the project entirely. Hello engineers would have drawn a new line on the map and accepted the detour. These engineers didn't reroute. They didn't tunnel either, because tunneling through rock of that composition would have taken years and created structural risks they weren't willing to accept. Instead, they brought in explosives and industrial drills, and they carved a V-shaped gap straight through the center of the mountain. A clean surgical cut. They split it in half. The blasts shook nearby villages. People woke up to what felt like earthquakes and stepped outside to find the skyline rearranging itself. The rock removal, the sheer volume of material excavated and hauled away could fill thousands of Olympic swimming pools. And the entire operation was completed in months, not years, because China wasn't building a road. They were building momentum. There's a difference. Roads connect places. Momentum changes them. So how do you actually build a bridge at 625 meters? You start by accepting that every problem you've ever solved before is the wrong size. The canyon walls slope at different angles. Geology doesn't care about your symmetry requirements, so the two main support towers couldn't be the same height. The north tower stands 262 meters tall. The south tower is 205 meters. They are not twins.
Yeah.
They're more like mismatched pillars holding up the same impossible idea. The total steel in the bridge, 22,000 tons of it, weighs 3 times more than the Eiffel Tower. 3 times. And all of it had to be lifted, positioned, and connected at heights where a construction crane's arm would just be waving in the open air. The world's biggest crane, Big Carl, stands 250 meters tall. You'd need to stack 3 of them to match the height of this job. So China engineered something else entirely, a cable crane system. A thick steel cable stretched across the canyon like a sky-level runway. Steel truss sections, each weighing multiple tons, were attached to a trolley mechanism and rolled across to their exact positions in the structure, hundreds of meters above the canyon floor. Workers operated in winds that made everything move. They worked in fog. They worked in conditions that would have shut down most construction sites in the world because shutting down wasn't an option. Every single piece of the bridge was mapped digitally before construction began. Engineers ran the entire build as a computer simulation first, a virtual version of every bolt, every cable, every load-bearing joint, identifying every potential failure point before anyone touched a single physical component. By the time they broke ground, they'd already built the bridge once in the computer, and torn it apart, and built it again, and torn it apart again, until the simulation survived everything they threw at it. Then there was the wind. This is the part that doesn't get talked about enough. When wind is squeezed through a narrow canyon, it accelerates a physics effect called the Venturi effect, the same principle that makes water shoot faster out of a pinched hose. Gusts in Huajang Canyon have been recorded at speeds comparable to express trains. A human being caught in that wind wouldn't walk, they'd fly, and a bridge that can't survive those gusts isn't a bridge. It's a very expensive debris field. Engineers use Doppler LiDAR technology, essentially shooting lasers into the air and measuring how they bounce back, to map wind patterns in 3 dimensions, in real time across the entire canyon. They then built scale models of the bridge and systematically destroyed them in wind tunnels, testing different design variations until one survived every condition they could simulate. The bridge's distinctive twin tower design isn't just aesthetic, it's aerodynamic. The shape was chosen because the wind told them to choose it, and even now that the bridge is finished, it hasn't stopped watching itself. Fiber optic strands are embedded inside the main cables, invisible threads of glass running through the steel every hour of every day. Light pulses through those strands, measuring exactly how much each cable is stretching under load, detecting temperature changes, tracking microscopic shifts in tension. The bridge monitors itself the way a living thing monitors its own vital sign. Hello engineers in an office somewhere can see the bridge's stress levels in real time. If something changes, they know before anything fails. Here's what this bridge actually is, though. Here's the twist you didn't see coming. China has spent hundreds of billions of dollars since 2012 building infrastructure in its poorest regions, highways, high-speed rail networks, airports, bridges. They call it a war on poverty. And the data says it's working. Guizhou is connected now. The isolation is over. Crops reach markets, students reach schools, families reach each other, the mountains are still there, the poverty is not. But Huajang Bridge was never just built for the people of Guizhou. It was built for you. You step in at the bottom of the canyon and rise smoothly and silently through 625 meters of open air until you emerge at road level, blinking at a horizon that shouldn't exist. At the top of the tower, a 2-story coffee shop with floor-to-ceiling views of a canyon so vast it barely looks real. On the underside of the road deck, a glass-bottomed walkway lets visitors stare straight down, 625 meters to the canyon floor. Their feet on transparency, their stomach somewhere below them. There's a bungee jump platform, an artificial waterfall spanning hundreds of meters of cliff face, plans already in motion for professional base jumping competitions, and an extreme sports complex in the canyon below. Hello. The infrastructure is becoming a destination. The destination is becoming a brand. China wants Huajang to become one of the most visited engineering sites on Earth, and they're not building it on accident. Every addition, the elevator, the glass walkway, the coffee shop with the impossible view, is a deliberate signal to the world. Come and see what we built.